In this video, we will discuss about LCMS sample diluent. First of all, we will understand what a ideal chromatogram looks like. This is something like ideal chromatogram where this gap is minimum, and if there is a widening of this gap, like and this chromatogram is not so good, as in this case there might be a possibility that these two might have combined together to give this peak. So this thing can be taken care of by using appropriate sample diluent. So what are the things we need to take care of while choosing the diluent is that what is our analytes, that is what is our sample, whether it is hydrophobic in nature, or hydrophilic, at this moment we are considering is a separate case, a single case, that is reverse phase chromatography, reverse phase LCMS. Most common used column in this is C18. So the more specific we talk about, the more useful it will be for the users. So we are talking about this reverse phase LCMS and C18. So what, how this C18 column function is that it has this stationary phase that is non-polar. Majorly it is non-polar. So non-polar will attract non-polars. So if our sample has this hydrophobic, then we need to ensure that hydrophobic are completely dissolved in the sample diluent. Otherwise, if they are not dissolved, they will not be able to pick up either by they will not be able to either reach to the column, because the injection that is used usually pick up only the sample diluent if they are not, if our samples are not properly dissolved. So in order to do that, usually what general thumb rule is used is that if our sample has this hydrophobic, they use 50% organic and 50% aqueous phase. Aqueous. Organic might be acetonitrile or methanol, and aqueous might just be water. Sometimes they also add like 0.1% formic acid. This is to improve the quality, this is to improve the possibilities of ionization, as mass spec only measure ions. However, let us consider some example to understand whether how good is this general guidelines. So if our method, that is the mobile phase that are running in the column, has like initial condition, let's just talk about one initial condition of the mobile phase. In the mobile phase, that is if we are using like 50% acetonitrile as considered and 50% aqueous water, okay, in that case, if the initial condition has like 30% acetonitrile and 70% if we compare the elution strength of the sample diluent in this case is stronger than the elution strength of the mobile phase. So what will happen is initially when the sample get mixed with acetonitrile, when samples get mixed with this mobile phase, then because of uneven distribution of the uneven homogeneous mixture formed in this case, as the because homogeneous distribution will not be formed in this case because of high strength of the sample diluent, and they do not get enough time to make a homogeneous mixture. So what will happen is that our sample will stuck up at different places in the column. So this might result in in a way that this our analyte will elute at different times. So if these two analytes are elute at different times, this might result in widening of this peak. This might result in widening of this peak because now the sample is not eluted at the same time but elutes at different time, and sometimes it might lead to merging of the peaks between the two different components. If let us consider our initial mobile phase has like 50% acetonitrile or more, then in that case our when our sample diluents with analytes and our mobile phase come in contact, then they will already in a homogeneous mixture. So in that case they will not segregate itself into different site, whereas in this case they will stuck up into a specific position based on its analyte strength and the column strengths. And when this elution strength increase in the mobile phase, then this will come out at a specific time and we will see only a single peak. So this could be the case. This could be the case with acetonitrile. In this case, we can see that we will observe that we will get a less widening peak compared to the previous case. If the concentration is higher, suppose like 70% acetonitrile, and this you can consider as minus 100%. And in that case, in the previous case also, if I have considered 50%, then that water should be like 50%. So in this case, if the initial acetonitrile is 70%, then since the volume of this mobile phase is higher than the volume of sample diluent, it will be easier to make a homogeneous mixture, whereas in case 1 it is difficult to make a homogeneous mixture. So now also they will make a homogeneous mixture, and in this time it will stuck up with the column at higher side because the mobile phase strength is higher, and now sample will elute faster compared to the second case. However, the peak widening is remain low in this case also. And one more thing need to understand, that in order to make a homogeneous mixture, it is essential if we can inject a minimum amount of sample in the column. So more concentrated sample we make is better for to get a good chromatogram. I think this video might help you to understand the basic concept between sample diluent and what needs to be considered, or how to select a appropriate sample diluent for our analytes. Thank you.